Bright Duty. Every student matters.
Hi students, now let's get to the portion of doing some questions which can be asked in examination. So the first question which is from is, why should a magnesium ribbon be cleaned before burning in air? So we studied this experiment wherein we were burning a magnesium ribbon on a Bunsen burner with a pair of tongs, and it turned dazzling white light and a powder was obtained. The question asked here is, why is it that before this reaction do we have to clean it? So we have to clean magnesium ribbon because on the surface of magnesium ribbon there is a deposit of magnesium oxide. The magnesium reacts with the air and forms magnesium oxide on the top of it, and that is why we need to clean it by rubbing it a sandpaper on it, and then it is good to go for the reaction. So magnesium ribbon gets covered with the layer of oxide by reacting with the air on the surface. That is why it needs to be cleaned with a sandpaper before reaction. The next question is about balancing. So let's just review, how do we balance an equation? First off, we write the equation. Secondly, we count the number of atoms of each element, and then we find a way to balance all of them out. So let's see here. So we have LHS, which is left hand side, right hand side. Here we have hydrogen and chlorine. So we have 2 each. Whereas here we have 1 each. So it's a very simple question, fairly simple question. You put a 2 here and this is what you will get. H2 plus Cl2 forms 2HCl. This is the balanced equation. It is one of the simpler kinds that you see that to double this right hand side, we will need to multiply it by 2, and that is why we have added 2 in front of the HCl. And now the equation is balanced. As you can see now, the new RHS side looks like 2, 2. So here you can see 2 hydrogen, 2 chlorine, 2 hydrogen, 2 chlorine. So the equation is balanced. Now let's do this one. It's a little trickier than the before. So here we have a lot of elements. Let's start. First off, we have to convert it from the word equation into the structure equation. So barium chloride, we know barium has valency of 2, so BaCl2. Aluminium sulfate, again aluminium's valency is 3, sulfate is 2. Then forms barium sulfate, both valencies 2, aluminium valency 3 and chlorine valency 1. So this gives us the equation BaCl2 plus Al2SO4 3 forms BaSO4 AlCl3. Now let's try to balance this equation, because as we can see, it's not, the number of reactants and products are not equal. So we have barium, we have chlorine, we have aluminium, we have sulfur and we have oxygen. Barium is 1 here, 1 here. So chlorine, here we have 2 and here we have 3. Aluminium, here we have 2, here we have 1. Sulfur, here we have 3, because it's this 3 gets multiplied. So sulfur we have 3 and here we have 1. Oxygen we have 12 and here we have 4. So let's first start by balancing out the metals. It is the best way to solve an equation, to start by balancing out the metals first. So if we have to balance out aluminium, or if you're talking about barium, we can start with either of them first. We know that barium is already balanced out, so we will not start with that, rather we will start with aluminium. Now aluminium is 2 here, but it is 1 here. So that means if I add a 2 here, aluminium will get balanced out, this will become twice, right? So this is one addition that we are doing. We are adding a 2 in front of Al because of this reason. Now if we do that, the number of chlorines becomes 6. Now to make this also 6, we will have to add a 3 here, right? Because the aluminium, because on balancing aluminium, the number of chlorine atoms changed. Now to balance chlorine atoms, we will need to change the reactant side, and here we have added 3 for that. Now chlorine is balanced at 6 and this side also becomes 6. But now barium has become 3. So let's add a 3 here. So both sides have equal number of barium. Now barium is sorted, calcium is, chlorine is done, aluminium is done. Now let's check for sulfur and oxygen, because they have also changed when we added this 3 here. Now here we have 3 sulfur atoms. So that is also again not a problem, and 3 fours are, we have 12 oxygen atoms. So this means by doing this we have justified for all the atoms that the law of conservation of mass is restored and the equation is balanced. How do we start? We start with the metals first. We saw barium was already same on both sides, so we didn't start with barium, we started with aluminium. You can start with either if both are to be balanced. Then you move on to seeing what changes it brings in other atoms and the subsequent changes, which will result in a finally balanced equation like you can see here. So this is the final balanced equation: 3BaCl2, Al2SO4 3, 3BaSO4, 2 AlCl3, right? Now let's do one more example. It is sodium plus water. So sodium you know is Na, water you know is H2O, form sodium hydroxide and water and hydrogen gas. Let's start. We only have 3 elements here. So there is sodium is 1 on each side, hydrogen is 2 here and 3 here, oxygen is 1 here and 1 here. So on the surface it seems obviously we have to start with hydrogen because other elements are balanced already. Now you know that 2 cannot be converted to 3, right? So what we will do is we will make it into 4. We make this, we put a 2 here, now hydrogen becomes 4. Now to make this 4, we cannot change this because it's already an even number, but we can add a 2 here. So it will be 2 plus 2, 4, right? So that is why I add a 2 here. But on adding a 2 here, what I will have to do is I'll also have to add a 2 here, because the number of sodium has changed to 2 now, and here it was already 1, so I add this 2. Now let's check the number of oxygen. Oxygen is 2 here and 2 here. So oxygen is also balanced out on its own. So this gives us the equation 2Na plus 2H2O forms 2NaOH plus H2. What we did here was we started with hydrogen because initially that was the only atom that was not balanced. When we tried to balance hydrogen, we saw that sodium now also needs to be changed. So we added a 2 here to fix the right and left hand side balance, and in that process we already fixed oxygen. So the solution is with us. 2Na plus 2H2O forms 2NaOH plus H2. So this question, next question is about again balancing. It says write a balanced chemical equation with state symbols for the following reaction. So what are the state symbols? State symbols are solid, liquid, gas, aqueous. These are the 4 state symbols. If you are asked, you have to write them. Generally you can also write them, but if asked, then definitely keep in mind to write them in brackets with every reactant and with every product. So it says solutions of barium chloride and sodium sulfate with water. So don't confuse water by adding H2O to the equation. It's a solution, which means we have to write aqueous in front of both the reactants. Gives rise to insoluble barium sulfate and solution of sodium chloride. So whatever is insoluble will be solid, because that is why it is settling. It's not liquid, that is why it's not mixing. So you know that this is the equation which we have also done in precipitation. So BaCl2 aqueous forms, reacts with Na2SO4 again aqueous, forms BaSO4 solid, which is actually the precipitate, and NaCl aqueous because it is again mixed in water. Now let's see what if this equation needs to be balanced or not. We have barium, we have sodium, we have chlorine, we have sulfur, and we have oxygen. Barium is 1 here, 1 here. Chlorine 2 here and 1 here, sodium 2 here and 1 here, and sulfur. So sulfur is 1 here, oxygen is 4 and 4. So it seems very simple. You can see that there are only 2 elements which are less on the product side, and they are in one compound. So if I put a 2 here, my equation is balanced. It's very simple. Right, so once you make this kind of a table, you will clearly be able to see what is it that you need to start with and what do you need to balance. It's not important to show this table in exam, but I would suggest you do that because drawing this table helps you get a clearer picture of how you're supposed to go about balancing an equation. So this gives us our final equation. The only balancing that needed to be done was that NaCl, two molecules of NaCl were being produced. Now let's move on to the third part of this question, which talks about solution of sodium hydroxide in water. So again, because it's in water, we call it aqueous. Sodium hydroxide is NaOH, reacts with hydrochloric acid solution in water, that is why again aqueous, to produce NaCl aqueous and water. Okay, so this is why we have given this equation like this. Now if we have to see its balancing, let's start. We have sodium, we have hydrogen, we have chlorine, we have oxygen. Sodium is 1 here, 1 here, oxygen is 1 here, 1 here, sorry, hydrogen is 1 here, 2 here, sorry, hydrogen is 1 and 1, 2 here and 2 here, and chlorine is 1 here and 1 here. So this equation is already balanced. It's balanced on its own, so we don't need to do anything to balance it now. This equation is perfectly balanced. Now let's do some interesting extra questions which are not from your book, but they can be asked from examination point of view. So let's see this question. It says there's a magnesium ribbon which is being burnt in oxygen. We have started this activity to give a white compound X accompanied by emission of light. If the burning ribbon is now replaced with in the atmosphere of nitrogen, it still continues to burn with and produces a compound Y. Identify the compound X and Y. So we know that when magnesium burns with oxygen, it produces magnesium oxide, right? And this is the product that would be created when we are burning a magnesium ribbon in air. So that is why X is magnesium oxide. Now Y you have not studied before, but if you try to understand using your concepts of valencies, you see that nitrogen is also present in the air, and if you are burning something in the presence of nitrogen, instead of oxygen, nitrogen would participate in the similar reaction. So here you can see that magnesium also reacts with nitrogen, and because magnesium's valency is +2, nitrogen's valency is -3, the compound found is Mg3N2. And that is exactly what Y is, magnesium nitride. So this is a question which is a little tricky because you have not studied about reaction of magnesium and nitrogen, but it works in the same fashion as it was for oxygen. Okay. The second part is write the balanced equation for when X is dissolved in water. Now you have already studied this equation. It is when we add MgO to water, what happens? So you know that MgO mixed with water forms MgOH whole twice. It is an alkali, MgOH whole twice is a base which is formed on mixing a metallic oxide of magnesium with water, right? So let's move on. So that is all for this chapter. We have covered the questions related to balancing of equation, and in this part we also covered the activities like burning of magnesium ribbon and general questions related to the concept of balancing.